Hello, I'm Dane, and this is Dan Explains. I've done a few videos lately on the possibility of terraforming smaller bodies like the Moon, or even the planet Mercury. If we can terraform temperate worlds like the Moon, and hot worlds like Mercury, why not see if we can terraform cold worlds like the moons of Jupiter and Saturn? Well, it may not be worth it even if we could. Let me explain why. First off, my videos are fairly short, so I don't want to go over all the details I covered in previous videos. So before watching this video, you really need to watch at least 2 of the previous videos I've already done on terraforming. I'll link them in the description. That being said, the technique for terraforming cold worlds would actually use a similar technique to the one that I suggested you would use to terraform hot worlds like Mercury. To remind you, in the case of Mercury, the organisms that created the upper layer of the atmosphere would be designed to absorb as much visible light as possible, while letting the infrared light pass through. That way, they reduce the energy coming from the sun and let the heat energy from the world below pass back out into space. On a cold world, the organisms would have to be engineered to do the exact opposite. This could be accomplished by making the organism's optimal photosynthetic spectrum in the infrared to red rather than the whole spectrum like you would with the Moon or Mercury. This would cause the world's atmospheres to be bluer in appearance than the warmer worlds, due to the extra absorption of light on the red end of the spectrum. The goal of retaining as much heat as possible is obviously to keep the world warm. The organisms could be engineered in such a way to act as a thermostat, like I mentioned in my Mercury video, where they absorb more infrared light if the temperature gets too cold, and less if it gets too warm. The advantage to the outer moons of the gas giants is that, unlike the Moon and Mercury, they already have the needed volatiles to terraform them, mostly in the form of water ice. This is starting to sound pretty doable, but what are the cons? Well, one issue is that many of the worlds sit in the radiation belts of their parent planet, and unlike Mercury, where you might be able to set up a protective magnetic field using the organisms I described, and the world's super-rotating atmosphere, the moons receive too little energy from the sun for that to work. Titan, the only moon with an atmosphere, does have a super-rotating one like Venus. However, because of the lower amount of sunlight received, the rotation speed of the atmosphere is relatively slow and weak compared to that of Venus, or what a terraformed Moon or Mercury would have. Although the heat generated by the organisms on the sun-facing side of the world may help a bit. Even with worlds where radiation is not an issue, like with Jupiter's moons Callisto and Ganymede, there is a much bigger problem that applies to pretty much all the worlds beyond the asteroid belt. They're beyond what's called the sun's snow line. Beyond the snow line, water freezes even when exposed to the vacuum of space. And in spite of what some movies like to make it seem, water is extremely abundant in the solar system, especially beyond the snow line. In fact, if you terraform them, almost all the worlds beyond the snow line would have oceans so deep they'd make the deepest oceans on Earth look like springtime puddles. Because of their deep oceans, they would have no solid surface. They would be a whole ocean. The only world where this is not the case, Jupiter's moon Io, would require a unique process to maintain its atmosphere, because it's highly volcanic, which means it should already have a substantial atmosphere, due to the gases released during volcanism. But it doesn't, because the intense radiation of Jupiter's inner radiation belts aggressively strip away Io's atmosphere, which either ends up lost in space, or crashing to Jupiter, causing its auroras. So Io's a unique case that we'll have to wait to cover in another video. Moving on to Saturn's moon Titan, it already has an atmosphere, and liquid on its surface. Well, it may have liquid on its surface, but it's not water. Its liquid is ethane and methane, and those rocks you can see on the surface are actually made of water ice. So, if you warmed it up, you'd have the same issue with the other worlds, except you'd also have an atmosphere that's deadly to humans that would have to be dealt with. But ice is very useful and relatively easy to work with as a building material in below freezing conditions, since we can easily melt it, form it into molds, And all you have to do to make it harden like concrete is let it cool off. So, although it may be possible, I would argue that the outer moons in our solar system, for the most part, are better left unterraformed, or at least not wholly terraformed. Thank you for watching. If you like this video and other topics ranging from theology to science, please press the like button. Subscribe to my channel and ding the bell to get notified when I post new videos. Also, please support me on Patreon to get extra content and special perks. Link in the description. The more people support me, the more time I can dedicate to making videos like this one. So, until next time, have a great week.